Hey, Jason here from Simply Swider. If your LG microwave is running but not heating food, you're in the right place. I'm going to walk you through the exact steps to diagnose and fix this problem yourself, potentially saving you $200 to $400 in service calls. Before we get started, if you run into any questions, jump into our Facebook group. Links in the description. We've got thousands of people helping each other fix their appliances, and I pop in there daily to help out. Now, here's the deal. We're going to cover some serious safety stuff up front, then walk through the most common problems from simplest to most complex. All right, folks, I got to be straight with you. Microwaves are one appliance where safety isn't optional. These things use high voltage equipment that can literally kill you even when unplugged. I'm talking about voltages up to 5,000 volts here. Safety first, people. Never, and I mean never, open a microwave without discharging the high voltage capacitor first. That capacitor can store a lethal charge for days after you've unplugged the unit. Here's the exact discharge procedure. First, unplug the microwave and wait 5 minutes. Put on insulated rubber gloves rated for electrical work. Using needle nose pliers with fully insulated handles, carefully touch both capacitor terminals simultaneously for 3 seconds to discharge any stored energy. Keep your body and other hand away from all metal surfaces during this process. And here's another thing. When you're handling the Magnetron, be extremely careful not to break those pink or white ceramic insulators. They contain beryllium oxide dust, which is highly toxic if you breathe it in. Don't ask me how I know that, but take this seriously. So let's start with door switches. These are your interlock switches that prevent the microwave from running with the door open. You'll know this is your problem if the microwave acts weird. Maybe it says shut door when it's already closed, or the turntable spins with the door open, or the timer counts down but nothing happens. I had this customer last month who called me in a panic because her microwave was possessed. Turns out it was just a bad door switch. Here's how to check them. Press each switch button and listen for a solid click. If the button feels flush or recessed, won't click, or you see melted plastic around it, that switch is toast. For testing, disconnect the wires and use your multimeter on continuity. Normally, open switches should read infinite resistance when not pressed, then drop to zero when pressed. Normally, closed switches work the opposite way. If you're getting bouncing readings or high resistance when it should be closed, the internal contacts are damaged. All right, so here's the big one, magnetron failure. This little guy generates the actual microwave frequency that heats your food. When it goes bad, you get all the sounds and lights, but zero heat. I've replaced hundreds of these things over the years. You can see on the screen right now what a failed magnetron looks like. If it resembles a burnt spark plug or the antenna dome looks melted, it's done. Here's the step-by-step test procedure. First, disconnect both wire terminals from the magnetron. Set your multimeter to the 200 ohm resistance setting. Touch your probes to the two terminals. A good magnetron will read between 0, 1 and 0, 5 ohms. This tests the internal heating filament. If you get a reading above 1 ohm or an open circuit, the filament is burned out. Then here's the critical test. Check for continuity between each terminal and the metal casing. This should read infinite resistance. If you get any reading to the case, the magnetron is shorted to ground and needs replacing. Magnetrons can't be repaired, so if it fails either test, you're looking at a replacement. Next up is the high voltage diode. This component works with the capacitor to convert AC power to DC and doubles the voltage to nearly 5,000 volts for the magnetron. Now here's where most people mess up. You can't test these diodes with the standard multimeter's diode function. The forward voltage drop is 5 to 8 volts, but most multimeters only put out about 5 volts. Here's the simple 9-volt battery test. Connect your 9-volt battery positive terminal to one end of the diode, then connect your multimeter between the battery negative and the other diode terminal. Set the meter to DC voltage. You should see 5 to 7, 4 volts in one direction. Now flip the diode connections. It should read near 0 or the full 9 volts, proving it blocks reverse current. If both directions show similar low readings, the diode is shorted and failed. If it drops to near 0 in both directions, like 0.07 volts, the diode is shorted and dead. The high voltage capacitor is another critical component. When this fails, your high voltage circuit shuts down completely. A shorted capacitor acts like a giant wire and will blow your main fuse immediately when you try to heat something after you've safely discharged it. And I can't stress this safety step enough. Here's how to test it. Set your multimeter to continuity and probe across the terminals. If it beeps or reads 0 ohms, the internal plates are touching and the capacitor is dead. Also test each terminal to the metal casing. Should be no continuity there either. If your meter has a capacitance function, the reading should be within 3% of what's printed on the side, typically 0.8 to 1.2 microfarads. Now, if you've got an LG inverter microwave, there's a specific problem pattern I see all the time. You press start, it runs for about 2 seconds, makes a noise, then completely shuts off and drops oscillation. This is usually blown diodes on the inverter board, specifically on boards ending in 05, 06, or 07. Here's something critical most people don't know. When you reinstall that inverter board, you absolutely must ensure the ground wire is securely connected to the chassis. If that board isn't properly grounded, the oscillation will spark and scatter, which can instantly destroy the board again. I've seen folks replace the same board 3 times because they missed this step. Finally, let's talk about your safety components, thermal fuses and thermostats. These monitor the temperature and shut things down if the microwave overheats. If one of these trips, you'll lose power to the heating components entirely. Testing is straightforward. Remove the leads and check for continuity. If your multimeter reads open circuit at room temperature, the fuse is blown. These can't be reset, so you'll need a replacement. Same goes for your mainline fuse. If it's blown, find out why before replacing it, because a shorted component will just blow the new fuse immediately. The Magnetron is going to be your most expensive component. You're looking at anywhere from $80 to $200 depending on your model. Here's my repair or replace rule. If your microwave is over 7 years old and the Magnetron has failed, compare the total repair cost to 50% of a new microwave's price. If the repair exceeds that threshold, replacement usually makes more sense. For example, if a new comparable microwave costs $200 and your Magnetron repair would be $150 including labor, you're better off buying new. Door switches are pretty affordable, usually between $15 and $35 each. Most microwaves have 3 or 4 of them, but you typically only need to replace the one that's failed. Easy DIY fix if you're comfortable with basic wiring. High voltage diodes run about $20 to $40, not a huge expense, but make sure you get the right voltage rating. These aren't universal parts, so you'll need the exact replacement for your model. All right, let's talk about what you're looking at cost-wise if you need to replace parts. Way cheaper than calling someone like me for a service call, that's for sure. You can see on the screen right now the most common LG microwave models that experience these heating issues. Maybe you'll spot your own model there. These problems aren't unique to LG either. This failure pattern shows up across brands because they all use similar high voltage systems. That's how you tackle an LG microwave that's not heating. Here's your action plan. Always discharge that high voltage capacitor first. Safety isn't negotiable. Then follow this testing order. Door switches first, 5-minute check, then magnetron, 10 minutes, followed by the diode and capacitor, 15 minutes each. This sequence goes from safest to most complex and catches about 90% of heating failures. Document your test results as you go. It'll help if you need to order parts. Early warning signs to watch for: intermittent heating, arcing sounds, or burning smells usually mean components are starting to fail. If you guys know someone who's having appliance troubles, please send them the link to this video or a link to my channel, where I have tons of other videos showing how to fix pretty common issues with appliances, sometimes for free or as little cost as possible. It sure beats having a repairman come out and spending several hundred for them to fix it when it could be something so simple. If this helped you get your microwave heating again, hit that like button and drop a comment below. Let me know which fix worked for you. Really helps other people with the same problem. And if you haven't already, please subscribe to the channel. We'll get this out to more folks who need to save some time and money. Thanks for watching, and I hope you guys have a great day.